In this case study, the symptom we are observing is that ping works but Telnet doesn't. Specifically, we are seeing this problem between router 7 and the host. Router 7 can successfully ping the host, but router 7 cannot telnet to the host. Looking at the configuration, we see that NAT is configured with a static NAT entry that will translate the local address of the host, which is 10.10.3.4, to a global address of 172.16.100.4. E0 is the inside interface, and S1 is the outside interface. Therefore, we know that when router 7 attempts to communicate with the host, router 7 sends packets to the global address of 172.16.100.4. One thing we may want to do at this point is check for the appropriate entries in the routing tables of the routers. Looking at the routing table of router 3, we see that it knows how to get to router 7 via serial 0, so we know that router 3 has a route to the destination. Router 7's routing table shows that it also has a route to the host network via the top router 172.16.5.1. So as far as we can tell, the routing looks good. At this point, we have enough information to figure the problem out, but we'll continue with our troubleshooting. Based on our configuration, what will the packets look like as they transition the network? First, our NAT translation table will be populated with the inside local and inside global addresses defined in the static NAT command. When router 7 sends packets to the host, the packet will have a source address of 172.16.5.7, which is router 7's address, and a destination address of 172.16.100.4, which is the inside global address for the host. Once the packet reaches router 3, the translation table gets checked, and we find a valid translation. The packet then gets translated and routed out the E0 port of router 3 towards the host. Here we have the return packet from the host with a source address of 10.10.3.4 and a destination address of 172.16.5.7, which is router 7. The first thing that would take place is the router would check for a valid entry in the routing table for the destination of the packet. We checked this earlier and determined that router 3 does have a route for router 7's network via serial 0. Once the route lookup takes place, the packet is checked against the translation table where we find a valid translation for the inside local address. The respective translation is then made and the resulting packet is sent towards router 7 with a source address of 172.16.100.4, which is the inside global address, and a destination address of 172.16.5.7, which is the outside global address. Now that we've illustrated what should be happening, using debug commands lets us monitor the packets that router 7 is seeing. Note that running debug on a production router can quickly use up a router's resources and cause it to crash. It is always recommended that at the very least you run debugs against an access list and log the messages to a buffer or syslog server. In some cases, this may not be sufficient. Here we want to look at the ping packets and the telnet packets, so we're creating an access list that will permit any ICMP packets so we can see the pings, and any TCP packets that use the telnet ports so we can monitor the telnet. The access list will be used with debug IP packet command, so we'll only see packets permitted by the access list. The command to enable this is debug IP packet 177 detail. Here we can see that we have enabled debug with the command debug IP packet 177 detail on router 7. We have also issued the ping, which is successful. The first packet we see is the ICMP echo packet sourced from router 7, destined to the inside global address for the host of 172.16.100.4. Then we see the return packet from the host. Looking closely at the debug message, We notice that the source of this packet is the inside local IP address of the host. This means that router 3 did not translate the packet as we thought it would. This exchange of packets continues. Running the same debug, we will take a look at the Telnet packets when telnetting from router 7 to the host. The first packet we see is the SYN packet sent from router 7 destined for 172.16.100.4, which is the inside global address for the host. Second, we see a SYN ACK packet from the host, but the source of this SYN ACK is the inside local address of the host, 10.10.3.4. Since router 7 received a SYN ACK from an unknown source, it sends a reset to the inside local address of the host, 10.10.3.4. In this case, router 7 sends the reset towards the top router, 172.16.5.1, which is router 7's default gateway. Since the top router doesn't know how to get to 10.10.3.4, it replies with a host unreachable message back to router 7. At this point, we can safely say that router 3 is not translating packets destined for router 7. We can continue to run debug commands or use show commands to try and figure out the reason. One thing we notice with the debug command is that return packets sourced from the host destined for router 7 take the path through router 3's serial 0 interface. As you can see in the configuration, NAT is not configured on serial 0. Therefore, packets that take this path will not be translated. So what we have here is an asymmetric routing scenario where NAT does not occur on one of the paths, causing TCP traffic to fail. Why does ping work? A router sending an ICMP echo looks for an ICMP echo reply which has the same ICMP identifier value of the ICMP echo request. If it receives one, then the ping is successful. It doesn't matter what the source IP address of that packet is. In this case, the solution is quite simple. Enable NAT on serial 0 of the NAT router. Or make sure that the path from the host to router 7 goes through serial 1.